Recall that the whole concept of relativity, Einstein is just trying to say energy is equal to mass times c raised to the power 2. That is the speed of light, which is assumed to be constant by Einstein. Now, Einstein went further to say, okay, general relativity. He brought about the general relativity. He said in general relativity, he was not talking about space, time, and gravity. Now, he's not trying to explain. Einstein used the general relativity to tell us that the reason why someone was coming down or falling down and feeling weightless is because the space, the space absorbs the person's weight. Einstein is a great scientist. He is a great scientist. He said the space absorbs your weight. According to what Einstein said, he said that the speed of light must be constant for all objects. And now we have traveled a distance up of space. So why gravity is acting? Because there's one mistake a fan made the last time I saw physics. The fan said that the space curvature is gravity. And I said, no, space curvature is not gravity. Space curvature is the effect of gravity on space. The effect of gravity. Because, okay, if you are throwing something down now, that force that is pulling you down is the force that is causing the curvature. The curvature is what is streamlining it, making the earth to be spherical in shape, and it's streamlining it. Look at it's streamlining, making the earth spherical in shape, making the earth spherical and spin round, making the earth round. And that is what they call this curvature. This space curvature is an effect. There's a force there, and that's the force of gravity, right? But it's curving it, and that is what is absorbing, making you fall weightlessly, because the earth is in turn is moving. And let me tell you one beautiful analogy in it. The beautiful part of it is that the earth is moving as we. Even if you think you're static, the earth is moving. And that is why all those reactions, you fall against gravity, you definitely fall weightlessly until you get to the ground. Maybe you bruise maybe it depends on the distance you fell. Einstein was just trying to tell us that nothing is absolute, that everything is relative to the observer. How you see it is not how I see it. If I sit down here and see something, you sit down there and see it with respect to time. And also, Einstein is just trying to also tell us that your time and my time may not be the same depending on our distance. Now, one last thing that Einstein said, there's something beautiful that Einstein discovered in all these things to prove that this thing is right. Because he thought, and he was trying to counter what Isaac Newton said about gravity, but Newton could not properly integrate the both by saying, okay, all objects act under the gravitational force, but when an object fell, he couldn't. Then he had to initiate the gravitational pull, the principle of the gravitational pull. That was when he initiated it. But Einstein said, no, you can't tell me that, because if I'm there, you want to tell me that something is pulling. And logically, it's true, because if you're saying that something is pulling down, everybody could have been falling somewhere that they don't know and falling to infinity. That is why he now brought out the principles of relativity to say that there's no absolute measurements. The beautiful part of it is that he was able to explain why. And why you are falling weightlessly, according to, instead of you saying, according to Newton, instead of you saying that you are being pulled by gravitational force, you should rather say that the earth is absorbing your weight. You should rather say that the space is absorbing your weight in its curvature. Let me tell you one last thing, one beautiful thing. You know, the speed of light is the standard measurement. And I can estimate us to understand by using E is equal to c squared. It's a standard measurement, right?